Hi friends, this is Taneru Hemant Kumar, studying in Sri Venkateswara College of Engineering, 6th sem. Today our subject is non-conventional energy resources. The topic of the subject is solar photovoltaic system with its application. Let's go into it. First, the components are solar array, cabling, mounting systems, solar trackers, and solar inverters, change controller, and photovoltaic system. A photovoltaic system also photovoltaic power system, solar PV system. PV systems are casually solar array is a power system designed to supply usable solar power by means of photovoltaics. Photovoltaics is a method of converting solar energy into direct current electricity using semiconducting materials that exhibit the photovoltaic effect. A photovoltaic system employs solar panel composed of a number of solar cells to supply usable solar power. Power generation from solar PV has long been seen as a clean, sustainable energy technology which draws upon the planet most painful and widely distributed renewable energy source. Tracking. Fixed of tracking array. The PV array may either be fixed sun tracking with one axis of rotation or sun tracking with two axes of rotation. The default values is a fixed PV array. PV array tilt angle 0 to 90 from a fixed PV array. The title angle is the angle from horizontal of the inclination of the PV array, 0 horizontal, 90 degrees vertical. For a sun tracking PV array with one axis of rotation, the title angle is the angle from horizontal of the inclination of the tracking axis, and the title angle is not applicable for sun tracking PV arrays with two axes of rotation. The default value is a title angle equal to the station's latitude. The normally maximum annual energy production increase. The title angle favors energy production in the winter while decreasing the title angle favors energy production in the summer. PV technology classification: thin film technology, silicon film technology, monocrystalline, polycrystalline. Going to the next PPT. The film technology. Silicon deposited in a continuous on a base materials such as glass metal or polymers. The efficiency ranges from 5% to 13%. Thin film crystalline solar cell consist of layers about 10 thick compared with 200 to 300 layers for crystalline silicon cells. Pros: low cost substrate and fabrication process. Cons: not very stable. And the silicon crystalline technology. In the silicon crystalline technology, currently makes up 86% of PV market, very stable with module efficiencies 0 to 16%, monocrystalline Si cells. Conversion efficiency for this type of cells ranges from 13% to 17% and can generally be said to be in wide commercial use. In good light conditions, it is the most efficient photovoltaic cell. Polycrystalline PV cells. The production of these cells is economically more efficient compared to monocrystalline. The efficiency ranges from 10 to 14%, and the polymorphism is a and the polycrystalline or multicrystalline solar panels are solar panels that consist of several crystals of silicons in a single PV cell. Several fragments of silicon are melted together to form the wafers of polycrystalline solar panels. In this case of polycrystalline solar panels, the vat of molten silicon used to produce the cells is allowed to cool on the panel itself. These solar panels have a surface that looks like a mosaic. These solar panels are square in shape and they have a shining blue hue as they are made up of several crystals of silicons. As there are multiple silicon crystals in each cell, so polycrystalline solar panels allow little movement of electrons inside the cell. These solar panels absorb energy from sun and convert it into electricity. And going to the next, working of solar cell. Photovoltaic cells are made up of at least two semiconductor layers, one containing a positive charge, that another a negative charge. Sunlight consists of little particles of solar energy called photons. As a PV cell is exposed to this sunlight, many of the photons are reflected, pass right through, or absorbed by the solar cells. When enough photons are absorbed by the negative layer of the photovoltaic cell, electrons are freed from non-negative semiconductor material due to the manufacturing process of the positive layer. These freed electrons naturally migrated to the positive layer, creating a voltage difference similar to a household battery. Whether the two layers are connected to an external load, the electrons flow through the circuit, creating electricity. Each individual solar energy cell provides only 1 to 2 watt to increase power output. Cells are combined in a weather tight package called solar module. These modules, from 1 to several thousands, are then wired up in several and are parallel with, with one another into what's called a solar array to create the desired voltage and amperage output required by the given project. This is the working of solar cells. Hope you guys. Thank you.